Hey guys, I'm the Cyborg Sheep, and welcome to the Weekend Post. In this video, we are going to be continuing Robot in 3 weeks. In case any of you are wondering what the heck is going on, I'll get into that in the next video, I promise. Alright, so after putting some thought into it, I think I found a pretty solid location now. It's not optimal, but it'll have to. This is probably the best out of probably some of the other locations. So let's get sticking it down, setting it up. Alright then, everything looks to be set up. So, now it's time to start building the robots. Alright, as a base to which all of my attachments and additions will go, I'm using the Educator robot. The one I have built here is slightly modified from the original instructions, but the modifications don't matter in this case for you. You can just build it exactly the same way it tells you in the instructions. The modifications I've made are mainly because I didn't get the core set. I have the basic home set. That doesn't include a lot of the parts that the core set includes. Alright, so in this video, I'm not going to be doing any programming. That will be the subject for next video. The thing I will be doing in this video is all the construction required to get this robot ready for programming. There might be some adjustments we'll make to the build in the next video. However, today we're just getting it ready. Now, the first thing you do before you do any construction or any work on any of these missions is to build a jig. Consistency in these games is a must. So, build a jig. It's going to save you so much trouble in the future. Now, my jig will look slightly different than yours because in this case, I don't have walls to reference my robot off of, so I think I have to look for external sources. One of those would be this table leg right here. Alright, after a lot of tweaking having been done to the robot and my jig setup, this is what I've ended up with. And as we can see, I've designed it in such a way that the two prongs of the jig will fit in to the two slots of the robot in such a way that it holds it in place when I'm setting up the robot. My setup is not the best. It definitely lacks the stiffness factor, as you can see by the very obvious flaw there that you would normally want out of these jigs. However, I think it should do fine for the levels of accuracy that we would want for this. Don't need NASA grade levels of accuracy. Alright, so one of the more important tests of the jig is, can the robot drive off perfectly straight, or is it going to be all cattywampus on us? So, contact. Success! It works. It's working. However, one of the one of the more troubling cases is the fact that my robot doesn't drive perfectly straight. That's not a case of the jig, that's because the speed of the two motors are unmatched. Now that can be fixed in the programming, which I will most certainly do. Alright, now I know that I can be at least reasonably accurate, it's time to start working on some missions. Alright, the first mission I'm going to start working on is Crater Crossing. Easiest thing first, am I right? Am I right? Am I right? Am I right? Alright, so continuing with this theme of easiest thing first, let's just try and push it across here without any modification. So, we can see that it should be able to clear that without any problems. However, if I get it just in the right way, you can see that these two arms right here are going to get caught underneath the bar and cause the robot to get stuck. So, we need to modify it in such a way that that won't happen. Simply by adding these two parts on the front, right here and right here, that allows our robot to drive across it without any problem whatsoever. Alright, now on the way to the mission that I've just completed, there's another mission that I could possibly complete, and that is this extraction mission. With my robot set up in the way that it currently is, this axle right here is almost at the right level to get in between this wall and this core sample right here, and if I drive forward, these will be pushed off here and the mission will be at the very least started off. Alright. That should work. This pull on the side of the robot can serve a dual purpose for the observatory mission. With the robot in this exact position, if I drive it forward, you can see that the observatory is rotated, and if I can get it to drive far enough, it ends up in the orange zone, which you can see right there. Now the problem is, once I get it into this orange bit here, this peg is now sort of trapped, and if I back up directly, it'll be moved backward into the white area. So I don't want that. Backing up is going to be a little bit difficult, but I can deal with that in the programming. So this next mission I'm working on is the payload mission. And this attachment is definitely going to need some upgrading. I'll do that in the programming phase though, once I'm actually dialing it in and getting the program right. But essentially, how it's going to work is, I'm going to use a color sensor to detect this line. Once I detect that line, the robot should be in the perfect position to lower the cart onto the platform. I'll then back out and lower it, and then raise it on the starting mechanism, and then drop the cart down the track. If I take this half off of the arm, I can use the other half to do this other mission right here. So if I haha, it's working. It works. Okay, that's perfect. We could definitely do that mission next. With the two arms installed on the front of the robot, in addition to my first run, all the other missions that I will do, I can also do this food production mission. Simply, I will use a color sensor to detect this T-shaped black line in two places. The end of it here, and the beginning of it behind the camera. And actually, so you can see there, it's sort of T-shaped. So I'll use it to detect this first, then I'll have it turn and drive until it sees the end of this and drive only so far, and we'll take a look at that now. So if I drive forward such so that it's like, oops, that's a little bit too much, but there we go. So if I drive forward that much, put it into the green, that will be some more points. Perfect. I tell you what, so many things I'm realizing that I can complete with just the downright simplistic stuff that I've built already. So, speaking of which, the emergency spacewalk mission can be completed with the little arm here that I made. If I just lift it, I can pick him up and drive around in some sort of way, and that may actually not work. Hold on a minute. Alright, I think I got it. I added on another link here. And now, if I pick up the spaceman, drive over, and then I can drop them in like so. That mission for the programming is going to have to be stupid accurate. You see how small this loop is? Yeah, not a lot of space in there. So that's going to be difficult, but I think we can do it. Hopefully. So I think you probably figured out by now that with my arm, basically anything with a loop can be manipulated with my robot. So, for this satellite mission, I'll of course be able to do that as well, once I figure out what it actually is. Anyways, let's move on to one of the harder missions. Alright, now suffice it to say, this one mission here, the escape velocity mission, I will not be able to complete. For the scope of this video, it's a little bit too hard, and within the scope of simplicity, I see no practical way of completing this unless you go to extreme levels. So, this will not be the one mission that I will complete. Alright, so I beefed up the gearbox a little bit. So let's see if we have a little bit more force when lifting this bar, and if it will actually work this time. Ah, still not enough. Well, I thought it would be possible, but turns out I was mistaken. I knew this was going to be hard right from the start, because they have that stinking friction piece in there. Didn't think it was going to be too hard because, like, I can lift it now. The amount of force I need is almost nil, but that sucks. Alright, that makes 2 of them now that we can't do. Alright, well, suffice it to say, I just couldn't do it. Now, that's not to say I didn't get somewhere. As you can see, I designed this little cloth thing here, and how it works is these are just the right thickness to fit in between the gap of these bricks and this top gray part here. This is a very weird part to grab onto, at least within Lego. What would have happened is I'd put the 2 beams in between the 2 bricks, and then I would have opened the 2 beams with the mechanism that I've made, and as you can see, it's being held purely by the Lego pieces right here. However, that's only half the story. The next big part to getting this thing working would be to figuring out how to power it. I have the single medium motor that's already moving the arm up and down, and I don't have any other motors. Now that's not to say I don't have motors. I do have the power functions motors, which would work optimally in this case. However, I don't have the right adapter for them at the moment. So therefore, I can't use them. I would also need to press that orange bar there, and I'm also not at maximum height, which increases the jankiness factor by a lot. Now I could group up all the mechanisms into one motor, but the timing for all the events would not be right, and I would need very complicated gearing to get it to be right. So at this point, I think I'm just going to keep trucking along with the missions that I can do. And with that being said, I think I'm going to leave the video at that. So, hope you guys enjoyed, and I'll see you in the next video.